National 3, revision for Unit 1. This is the second part. Unit 1 is broken down into 6 subsections. Subsection 1, chemical changes. Physical changes, easy to turn back, things like melting, boiling, and no new substance made. In chemical change, a new substance is always made. Things that indicate this are things like a colour change, gas given off, sound given off, light or electricity. It can make a solid, which is called a precipitate, and the temperature can go up, which is called exothermic, or down, which is called endothermic. The second section is reaction rates, where we look at how temperature increases reaction rate, how increased concentration increases reaction rate, how increasing the surface area by making the particles smaller increases reaction rate, and the use of a catalyst. With a catalyst, you need to remember that it is not used up in the reaction. What you start with is what you finish. Enzymes are what's called biological catalysts, and they're throughout your body. The third section is a periodic table. First thing to understand is atomic structure. An atom contains a nucleus. In the nucleus you have protons and neutrons, and around that in orbits are electrons. The proton has a positive charge, a mass of 1, and is in the nucleus. The neutron has no charge, a mass of 1, and is in the nucleus. The electron has a negative charge, with it being in shells or orbits around the nucleus. The elements are ordered in atomic number order on the periodic table. This is the same as the number of protons. You need to remember 3 groups. Group 1 is the alkali metals, Group 7 is the halogens, and Group 8 are the noble gases. And you also need to understand that in every group, the elements have similar properties. So all the alkali metals react with water, all the noble gases react with nothing. The periodic table is also split into 2 main groups. The metals, which are on the left and centre of the periodic table, and the non-metals, which are to the right of the zigzag line. You also need to be able to remember the test for a metal, which is that it conducts electricity. See the circuit in the other set of revision notes. Subsection 4 introduces the concept of compounds and word equations. In a word equation, you need to remember that all the reactants, what you start with, are on the left-hand side, while the products, what you finish with, are on the right-hand side. The arrow indicates that a reaction has taken place. You also need to understand the naming of compounds. This is that the first part of the name is usually the metal, i.e. sodium, and the second part of the name depends on how many elements are there. At present, we're just looking at 2, so I would finish with an "ide." So sodium sulfide indicates that we have sodium and sulfur present. Magnesium oxide would indicate that we have magnesium and oxygen present. Section 5 again looks at compounds, but in the context of mixtures, elements and compounds. An element is one type of atom. All iron are iron atoms. All gold are gold atoms. A mixture is where you have more than one type of atom, but they are not chemically joined. And a compound is where you have more than one type of atom, but this time they are chemically joined. Compounds have different properties to elements. Think of hydrogen and oxygen, both gases. When joined together, they make water, which is a liquid. Also in this section is an understanding of how to separate mixtures. Filtration separates a mixture of solid from a liquid. Think of sand and water. Evaporation is to separate a dissolved solid from a liquid, where you evaporate and get the crystals back. And distillation, where you separate liquids by their boiling point. Alcohol boils at 80, water boils at 100, heat a mixture up and you'll get pure alcohol back. Words that you need to know. A solvent. This is a liquid that does the dissolving. A solute. This is the solid being dissolved, and a solution is a solvent plus a solute. The last subsection is pH and how you measure it. This is done using indicators, generally one called universal indicator, which gives us a pH range of 1 for a strong acid, which would be red, through to 7, green, which would be neutral, all the way to 14, which would be purple, which would be a strong alkaline. you need to understand the idea of neutralization. An acid and an alkali are opposites of each other, and when they react together, they will give you water and a salt. An example of this would be acid indigestion tablets for when you've got stomach acid problems. You take these, they soothe the indigestion.